This lecture develops the theory of short-run exchange rate determination from the asset approach that's based on UIP. Our preceding lecture provided a model for how long-run or future exchange rates can be determined. This is one of the building blocks required in the UIP expression that suggests a model for determining the spot rate. This model is known as the asset approach to exchange rate determination. In the short run, currency is treated as an asset, the price of which is determined in the forex market by the UIP condition. As we have shown before, the UIP condition can be written in approximation form as the interest rate in the home country being equal to the interest rate in the other country plus the expected depreciation in the home country's exchange rate. So for two countries, say the United States and Japan, with the US being the home country, the UIP condition has the US nominal interest rate being equal to the Japanese nominal interest rate plus the expected depreciation of the dollar-yen exchange rate. Intuitively, the UIP condition states that the rates of return on the two investments must be equal to leave investors indifferent as to where to invest. The US interest rate is the rate of return on the dollar-denominated asset. The foreign or Japanese interest rate is the rate of return on the yen-denominated asset. When this yen rate of return is added to the expected depreciation of the dollar-yen exchange rate, the entire expression is called the dollar rate of return on the yen deposit. This allows the two rates to be fully comparable. Thus, foreign exchange market equilibrium holds when they are equal. The nominal interest rate therefore adjusts to keep the foreign exchange market in equilibrium whenever any of the other variables in the UIP expression change. We can depict the UIP condition or the foreign exchange market equilibrium graphically, as we show on this slide. With the price of currency, that is the nominal exchange rate, on the vertical axis and the rate of return on the horizontal axis, we have the analogues of a market with the rate of return on the home or US asset and the dollar rate of return on the foreign asset graphed to determine the equilibrium exchange rate and rate of return. As drawn, the rate of return on the US asset is a vertical function, as this is the home or US foreign exchange market, and the US interest rate is not determined by the exchange rate, but by events in the US money market. The dollar rate of return on the yen asset is, however, an inverse function, showing that high dollar-yen interest rates result in a low dollar rate of return on the yen asset, but lower dollar-yen exchange rates result in higher dollar rates of return on the yen asset. Intuitively, if the dollar-yen exchange rate is high, it costs too much to invest in the foreign asset today, which makes the rate of return in dollar terms not too attractive. But if the dollar-yen exchange rate is low, then it is cheaper to invest in the foreign asset today, which makes the rate of return in dollar terms very attractive. As with all markets, there will always be a move toward equilibrium if for any reason the exchange rate departs from that level at which UIP holds. So suppose the dollar-yen exchange rate was higher than the equilibrium level, which happens when the US rate of return is greater than the dollar rate of return on the foreign asset. This will make dollar deposits more attractive than yen deposits, and so investors holding yen will seek to buy dollars in order to invest in the US. This demand for dollars makes it appreciate, so that the dollar-yen exchange rate falls until interest parity is restored. Similarly, if the dollar-yen exchange rate was lower than the equilibrium level, then the dollar converted rate of return on the foreign asset is greater than the US rate of return, and yen deposits are now more attractive than dollar deposits. Dollar holders will seek to buy yen in order to invest in Japan, and this will cause the dollar to depreciate so that the dollar-yen exchange rate rises until interest parity is restored. These disequilibrium situations and the adjustments to equilibrium just described are depicted here. As shown, when the exchange rate is higher than the equilibrium rate, which is depicted in this case by the exchange rate in red, there is disequilibrium. The red arrow shows the adjustment that takes place toward equilibrium as the exchange rate appreciates. Similarly, when the exchange rate is lower than the equilibrium rate, as depicted by the exchange rate in blue, there is again disequilibrium. The blue arrow shows the adjustment back to equilibrium as the exchange rate depreciates. However, we do need to know what might cause the exchange rate to be where it is at any point in time. So we look again at the UIP condition for the foreign exchange market equilibrium, which has the interest rate in the home country being equal to the foreign interest rate plus the expected depreciation of the exchange rate quoted in direct terms. Rearranging this, we have the spot exchange rate as equal to the future or expected exchange rate divided by an expression given by 1 plus the home interest rate minus the foreign interest rate. The bilateral spot exchange rate is thus determined by three key variables: the future or expected exchange rate and the current nominal interest rates in both countries. This is where our last lecture comes in handy, as we have a model for explaining how the future or expected exchange rate is determined, that is, the monetary model based on PPP. We will need to also explain how the current nominal interest rates are determined. But first, let us see how these variables determine the spot rate, and then how changes in any of these variables in turn bring about changes in the spot rate. So if we have information on the nominal interest rates in both countries and an expected future dollar-euro rate, then plugging these into the formula gives us the current or spot exchange rate, as this illustration shows. In this illustration, because the nominal interest rate in the euro area is higher than that in the US, the dollar is expected to appreciate as the exchange rate is expected to fall from 1.218 to 1.20. This ensures that both investment alternatives are equally attractive. Consider another illustration. Suppose the pound-rupee exchange rate is 0.01 and the future expected rate is 0.0095. If banks in the UK are offering 3% interest on deposits, while banks in India are offering 6%, what would astute investors do in this situation? Well, they would have noticed that UIP fails to hold. That is, the nominal pound-rupee exchange rate is greater than the ratio of the future pound-rupee rate to 1 plus the interest rate differential between the UK and India, as computed. This makes pound deposits very attractive, and holders of the rupee will seek instead to invest in the United Kingdom rather than in India. This will lead to a demand for pounds and cause the pound to appreciate so that the spot pound-rupee rate falls until UIP is restored. A perhaps more intuitive explanation of the foregoing can be seen by checking whether UIP holds from a rate of return comparison. So under UIP, the rate of return in the UK, which is the UK interest rate, should be equal to the rate of return in India, which is the Indian interest rate, plus the expected depreciation of the pound-rupee exchange rate. It is seen that UIP does not hold, as the rate of return on the UK asset is greater than the pound rate of return on the Indian asset. Clearly, investing in the United Kingdom is more attractive than investing in India, and so rupee holders will want to purchase pounds to invest in the United Kingdom, and this causes the pound to appreciate and the spot rate to fall until UIP is restored. In this example, note that the expected depreciation of the pound rupee rate is negative 5%. That is, it appreciates by 5%. So for UIP to hold, the rate needs to depreciate by negative 3%. That is, to appreciate by only 3%. This happens by the spot rate appreciating today, so that over time it appreciates by less, that is by the 3%, in order to arrive at the expected future rate of 0.0095. Now that we have seen how the spot rate adjusts to keep the foreign exchange market in equilibrium, we will now show how changes in the determinants of the spot rate bring about changes in the spot rate. First, consider changes in the future exchange rate. If, for example, the future or expected dollar-yen exchange rate increases, then UIP fails to hold, as the rate of return on the US asset is now less than the dollar rate of return on the foreign asset. The dollar-yen spot rate therefore increases, that is, the dollar depreciates against the yen today to restore UIP. Similarly, if the expected or future dollar-yen rate falls, then this causes the rate of return on US assets to be higher than the dollar rate of return on the foreign asset. The dollar-yen spot rate today therefore falls as the dollar appreciates against the yen in order to restore UIP. We show these effects in the diagram on this slide. The initial outcome in the foreign exchange market is given by the black curves, and equilibrium occurs where UIP holds. If the expected dollar-yen exchange rate rises, the dollar rate of return on the yen asset curve shifts up and is now given by the red curve. UIP fails to hold at the initial spot rate, so the spot rate rises and the dollar depreciates today against the yen. If instead the future dollar-yen exchange rate had fallen, then the dollar rate of return on the yen asset curve shifts down and is now given by the blue curve. Again, UIP fails to hold at the initial spot rate, and so the spot rate falls. Thus, the dollar appreciates against the yen today until UIP is restored. Next, what if instead we had a change in the US interest rate? If the foreign exchange market was in equilibrium and then the US interest rate rises, then UIP fails to hold, as the US rate of return is now higher than the dollar rate of return on the yen asset. The spot dollar-yen rate therefore falls, as the dollar appreciates from the strong demand for it by yen holders. UIP is then restored. Similarly, if the US interest rate had fallen, then the spot dollar-yen rate rises as the dollar depreciates from the demand by dollar holders for yen in order to take advantage of the relatively more attractive dollar rate of return on yen deposits. So again, this continues until UIP is again restored. This is depicted in the graph on this slide, with the initial foreign exchange market conditions represented by the black curves. The market is in equilibrium when UIP holds. If the US interest rate increases, the vertical black line shifts to the right and is now the red line. UIP fails to hold at the initial equilibrium spot dollar-yen rate, and it falls as the dollar appreciates today in order to restore equilibrium in the foreign exchange market. Similarly, if the US interest rate from the initial equilibrium had fallen, the vertical black line shifts to the left and is now the blue line. UIP fails to hold at the initial equilibrium spot dollar-yen rate, and it now rises as the dollar depreciates today in order to restore equilibrium in the foreign exchange market. Next, we look at changes in the yen interest rate. If the yen interest rate rises, then the dollar rate of return on yen assets is now more attractive than the rate of return on US assets, so that there is demand for yen by dollar holders in order to take advantage of this. The result is that the spot dollar-yen rate rises as the dollar depreciates today. Again, this continues until UIP is restored. If, however, the yen interest rate had fallen, then the dollar rate of return on the yen deposit is now lower than the rate of return on US assets, so that yen holders now want to invest in the US. The result is an increased demand for dollars, so that the spot dollar-yen rate falls as the dollar appreciates today, and this continues until UIP is restored. Again, this is depicted graphically. The initial outcomes are provided in the foreign exchange market by the black curves. Now, with an increase in the yen interest rate, the dollar rate of return on yen asset curve shifts up as shown by the red curve, and the result is UIP fails to hold. This results in the spot dollar-yen rate rising as the dollar depreciates against the yen today. Similarly, with a decrease in the yen interest rate, the dollar rate of return on the yen asset curve shifts down, as shown by the blue curve. UIP again fails to hold. As a result, the spot dollar-yen rate falls to restore equilibrium, and this happens as the dollar appreciates from the strong demand for it by yen holders in order to invest in the higher interest-bearing investment in the United States. Let us now walk through a numerical example. Suppose that interest rates on deposits in the United States and Canada are 2% and 4% respectively. If the future US dollar-Canadian dollar exchange rate is expected to be 0.95, what is the current US dollar-Canadian exchange rate? Further, what will happen to this spot rate if Canadian interest rates fell to 2.5%? We can use the UIP formula for the spot rate to compute what it is given the known magnitudes of its determinants. And as computed, this gives us 0.969. Similarly, if Canadian interest rates instead were at 2.5%, again we use the spot rate formula, simply plugging in 2.5 where we initially had 4%. We obtain a spot rate of 0.955. So with a fall in the Canadian interest rate, the spot rate falls from 0.969 to 0.955. That is, the US dollar appreciates today in response to the fall in the Canadian interest rate. We can also depict these results in graph form, as we show on this slide. At the initial equilibrium in the foreign exchange market, as computed, the spot rate is 0.969. As Canada's interest rates fall, the US dollar rate of return on the Canadian dollar asset curve shifts down, as depicted by the blue curve. For UIP to be restored, the spot US dollar Canadian dollar exchange rate falls to 0.955, and the foreign exchange market is back in equilibrium. From the foregoing, we have seen that the asset model of spot exchange rate determination assumes that we know three variables: the future exchange rate, the interest rate at home, and the foreign interest rate. But how do we know what these three variables will be at any time? Well, the last couple lectures gave us a clear theory for how to determine the future or expected exchange rate. This was by using the monetary model of long-run exchange rate determination that was based on PPP. Our next task is to find a model by which we can understand how short-run interest rates are determined. And for this we turn to the money market, which is where interest rates typically serve as a price, and we shall proceed from there. First though, we have to keep in mind that in the short run, we typically assume nominal rigidity in the money market. That is, that prices are sticky. As the relevant price in the money market and with nominal rigidity, the nominal interest rate adjusts in the short run to keep the money market in equilibrium. I'll now briefly cover what we should already have known from our prior exposure to economics about the money market. So my coverage here is going to be somewhat brief. Money supply is determined by the country's central bank or monetary authority. Its level, MS, is therefore equal to some level called at M. Money demand, MD, is determined by national incomes and interest rates, and so it's given by a liquidity preference relationship, LIPY. Note that P is assumed fixed by short-run price stickiness. Hence, it is written as P bar. This contrasts with the long run, where P is fully flexible and is what adjusts to clear the money market. In the short run, which is where we're focused presently, P, the price level, is fixed, and the nominal interest rate is what adjusts to clear the money market. In equilibrium then, money supply is equal to money demand, or in real terms, the real money supply M over P bar is equal to the real money demand LIY. The short-run money market equilibrium is depicted in graph form on this slide. As shown, the real money supply is a vertical function in the nominal interest rate real money balances plane. This is because the level of money supply is determined by the monetary authorities and not by interest rates. The real money demand, however, is a decreasing function of the nominal interest rate for any given level of national income. That is, a high interest rate raises the cost of holding money in liquid form and earning no interest, so that the demand for money is low when the interest rates are high. Whereas the demand for money increases when the interest rates are low, as the cost of holding onto money is dominated by the liquidity preference for speculative purposes. The money market is in equilibrium at the intersection of both real money demand and real money supply. So if the interest rate was higher than the market generated equilibrium rate, then this means that the real money supply is greater than real money demand. This will cause the nominal interest rate to fall in order to encourage an increase in real money demand to mop up the excess money balances in supply. On the other hand, if the interest rate was lower than the market generated equilibrium rate, then the real money demand is now greater than real money supply. The interest rate will therefore rise to discourage the excess demand by making it costly to want to hold scarce money balances. So the market always returns to equilibrium where real money demand and supply are equal through the nominal interest rate adjusting. This is depicted on this slide. If there is a disequilibrium in the money market in the short run, the interest rate adjusts to return the money market back to equilibrium, as described previously. From the foregoing, we now have a model for determining short-run interest rates. The money market in the short run. When the key variables in this market, that is the money supply and real incomes, change, the nominal interest rate also changes, and its direction and magnitude of change can be predicted by knowing the direction and magnitude of the money supply or real income change. For example, when money supply increases, then because prices are sticky in the short run, the real money supply also increases, and real money supply now exceeds real money demand in the money market. The interest rate therefore falls to restore equilibrium. Similarly, if money supply is decreased, then the real money supply falls as well, as prices are sticky in the short run. Real money supply now falls below real money demand, and the interest rate rises to return the market to equilibrium. Again, these changes are depicted in this slide. An increase in money supply causes the real money supply function to shift to the right, and this causes the nominal interest rate to fall. A decrease in money supply causes the real money supply function to shift to the left, and this causes the nominal interest rate to rise. On the other hand, if we had an increase in real income, that is real GDP, then real money demand will increase to exceed real money supply, and the interest rate will rise to restore market equilibrium. And if instead we had a decrease in real incomes, then real money demand would fall below the level of real money supply. This will prompt the nominal interest rate to fall until the market is restored back to equilibrium. We again depict these changes here. An increase in real incomes Y causes the real money demand function to shift up, and this causes the nominal interest rate to rise. A decrease in real incomes causes the real money demand function to shift down, and this causes the nominal interest rate to fall. We now have all the building blocks needed to provide a theory of short-run or spot exchange rates. This is the asset model of exchange rate determination, because it is based on taking currency as an asset and determining its price by means of a foreign exchange market equilibrium, where this equilibrium is given by the uncovered interest parity condition. So if we are considering the dollar-yen exchange rate, the UIP condition again states that the interest rate in the United States is equal to the sum of the interest rate in Japan and the expected depreciation of the dollar-yen exchange rate. That is, the rate of return on the dollar asset is equal to the dollar rate of return on the yen asset. Rearranging this, we have that the dollar-yen exchange rate, that is the spot rate, is equal to the ratio of the future or expected dollar-yen exchange rate to an expression given by 1 plus the US interest rate minus the Japanese or yen interest rate. We know that the future exchange rate will be determined by the monetary model based on PPP, and that interest rates will be determined by their respective money market situations. So we can at any time determine the spot exchange rate if we have information on these three variables. In diagrammatic form, we have the asset model depicted here in partial form. On the right hand, we have the foreign exchange market from the US perspective, and we have hooked it up to the US money market, the depiction on the left hand side. Missing is the foreign, that is the Japanese money market. But if we need information on changes in that market, we can either rearrange the current setup to have the foreign exchange market from the Japanese perspective and then hook it up to the Japanese money market, or we can simply determine that from a standalone graph and infer its effects on Japanese interest rates in the foreign exchange market we have here. As depicted here, the US foreign exchange market is in equilibrium at some specified interest rate and exchange rate. The US interest rate is in turn determined by equilibrium in the money market. We can begin to use the model by asking what happens when there is a shock or policy change that happens in any one of the countries in question. Our focus to begin with here is when such shocks or policy changes are temporary. Whenever we have shocks or policy changes that are temporary, they will not affect expectations, and therefore they will not influence the long run or future exchange rate. So given the equilibrium conditions holding in the money market and foreign exchange markets, any change that affects the money market will cause the nominal interest rate to change, and this will influence the relevant country's interest rates in the foreign exchange market, and this will result in a change in the spot exchange rate. For example, a temporary increase in US money supply by the Federal Reserve System. As depicted, this will cause the short-run real money supply function to shift out to the right. Money market disequilibrium results as real money supply exceeds real money demand. The US interest rate falls such that in the foreign exchange market, the foreign asset is now more attractive, as the dollar rate of return on the foreign asset is greater than the rate of return on the dollar asset. This leads dollar holders to want to trade for yen so as to invest in Japan, and this causes the spot exchange rate to rise as the dollar depreciates against the yen. As another example, suppose the US enters into a mild recession such that there is a temporary decrease in US real incomes. As depicted, the real money demand function falls in the US money market. This causes the US nominal interest rate to fall, and as a result, in the foreign exchange market, the foreign asset is now more attractive than investing in the US, which now has a lower rate of return. Dollar holders increase their demand for yen in order to invest in Japan, since the dollar rate of return on the yen asset is now higher. The result is the spot dollar-yen exchange rate rises as the dollar depreciates against the yen. At this point, an astute student might have realized what looks like a conflict in how interest rates affect exchange rates. In prior lectures, we might have seen that it was an increase in the US interest rate that caused the depreciation of the dollar. However, we are showing here that a decrease in the US interest rate causes a depreciation of the dollar, suggesting correctly that an increase in the US interest rate will cause a dollar appreciation and not a depreciation. Are these not conflicting results? Well, the answer is no. What should be kept in mind is that the earlier case had to do with the long run, whereas we are focused now on the short run. In the long run, the nominal interest rate is influenced only by expectations of inflation, as shown by the Fisher equation, and inflationary expectations are in turn influenced by money supply growth changes. Further, the resulting nominal interest rate change causes the price level, which is fully flexible in the long run, to change, and this is what causes via PPP in the monetary model the exchange rate to change. However, in this model, the asset model, prices are sticky, and the short-run nominal interest rate is influenced directly by changes in the money market. As we will demonstrate in the next lecture, in spite of this seeming movement in opposite directions due to short-run and long-run effects, all changes are consistent once we show how the variables transition from the short to the long run. So let us summarize what we have learned from this lecture. The UIP condition holding in the foreign exchange market provides us with a theory of short-run nominal exchange rates. The short run or spot exchange rate can be determined once we know the future rate and the nominal interest rates of the countries in question. We have provided full models that determine these. The monetary model and PPP will give us the future rate, and adjustments in the money market in both countries will give us the nominal interest rates. It's now clear that the spot exchange rate is primarily driven by interest rate changes when the policy is temporary, and interest rate changes come from changes in either monetary policy or in real incomes. The next lecture goes into the asset model in greater detail. But first, let us reinforce our understanding of our coverage so far by taking the quiz associated with this lecture. Then make sure to read through the whole chapter on the asset approach in the short run, and then get ready to listen to the next lecture.